When the rain came to the Maya world, it did not arrive softly. It came crashing out of a dark sky, hammering thatch, pounding stone, rushing down stairways, filling patios, turning footpaths into mud and low ground into temporary swamps. In the tropical lowlands of Mesoamerica, rain could be life, but in the wrong place, at the wrong time, it could also be chaos. And that is the first great surprise in the story of the Maya. For generations, we have been taught to think of the Maya as a civilization obsessed with drought, a people who watched the sky, prayed for rain, and struggled to survive the long dry season. That is true, but it is only half the story, because before the Maya had to survive months without water, they first had to survive the moment when too much water came all at once. They lived in landscapes defined by extremes. In many Maya regions, life was rainfall dependent. The seasons swung hard. The rains arrived, then vanished. In the southern lowlands, the dry season could stretch from January into May or June, while the wet season brought violent downpours and difficult decisions about where to build, how to move, and how to keep homes, food, courtyards, and stored water from being ruined. In the Puc Hills of Yucatan, the challenge was even more brutal. There were few permanent surface waters. The water table lay too deep to reach with pre-modern technology, and yet people built dense settlements there anyway. At first glance, it makes no sense. Why plant cities where the ground could flood in one season and offer no river in the next? The answer is that the Maya did not simply endure the rain. They engineered it. They studied slope. They studied stone. They studied how water hit a roof, where it ran, where it pooled, how fast it spoiled, how quickly it disappeared into limestone. They built homes above the splash and cities above the muck. They raised living spaces, pitched roofs to shed torrents, hardened surfaces with plaster, cut drains through architecture, stored runoff in hidden chambers, enlarged natural depressions into reservoirs, and in some cities forced streams under plazas so that urban life could continue above them. To stay dry in the Maya world did not mean hiding from water. It meant controlling its path, second by second, from the roofline to the ground. Today, some of the clearest evidence for that mastery comes not from standing temples, but from what can barely be seen at all. Across the Maya region, archaeologists using LiDAR have begun to see the hidden logic of ancient settlement in astonishing detail. Under forest canopy, the laser maps reveal depressions, berms, channels, platforms, terraces, reservoirs, and countless openings in the earth. In the Puc region especially, LiDAR has shown a landscape crowded with households and water features in a place lacking natural surface water. What once looked like scattered ruins now appears as an enormous hydraulic world, carefully managed at household scale and community scale at the same time. And once that pattern comes into focus, the old question changes. The question is no longer, how did the Maya survive there? The better question is, how did they make that landscape habitable at all? And there was a deeper paradox at the heart of the Maya landscape. A place could look drenched and still be thirsty. That sounds impossible until you understand karst. Much of the Maya world sat on porous limestone. Rain could pour from the sky in tremendous volume, soak the forest, rush across a plaza, and then vanish downward through fractured ground. In some areas, when forest was cleared, runoff moved even faster toward a water table that lay far below and was effectively inaccessible. So abundance on the surface did not guarantee security below. The Maya were living inside a hydrological trick. Water was everywhere when it fell and nowhere when they needed it to stay. That is one reason their engineering had to be so precise. They were not only catching rain, they were trying to stop a disappearing act. This is why so many Maya solutions look at first almost counterintuitive. Instead of spreading out randomly across the easiest ground, people often clustered where runoff could be organized and where architecture could help discipline it. Elevated precincts, paved catchments, plastered courtyards, and modified depressions all worked together because the natural ground alone could not be trusted to hold what the sky provided. At Tikal, for example, researchers describe a central precinct on an upraised ridge where major catchments fed reservoirs through directed seasonal runoff. In the Puc, where the lack of natural surface water was even more severe, household cisterns and communal aguadas became the difference between a settlement and an impossibility. The Maya were not just adapting to climate, They were correcting for geology. One part of the answer begins with something so ordinary it is easy to miss. The floor. For a Maya family, dryness started before the roof. It started with elevation. Archaeologists studying daily life in classic Maya communities note that houses and palaces were often placed on hills or artificial platforms to catch breezes and avoid flooding during tropical rains. Even middle-status homes often sat atop smaller raised platforms. That lift mattered. A few inches, a few feet, the difference between a livable home and a soaked one. In a storm, higher ground kept sleeping mats above rivulets, hearths above mud, and daily life above the churn of runoff. The platform was not decoration. It was the first defense against a wet world. And then there was the roof. The simplest Maya homes were often made of wood and thatch, and ironically, those modest houses may have handled tropical moisture better than elite stone residences in some ways. Scholars note that wooden homes allowed more light and air to circulate, making them drier and sometimes cooler. A steeply pitched roof of palm or grass was not primitive improvisation. It was climate intelligence. Under heavy rain, water slid off fast. The eaves pushed runoff away from walls. Air moved through the structure and helped the interior dry. These were homes designed by people who understood that in the tropics, breathability could matter as much as strength. Elite architecture solved the same problem differently. Royal families lived in stone palaces, with plastered walls, murals, and high vaulted chambers. Their buildings stood on commanding platforms, often in the best drained parts of the built landscape. Thick masonry and lime plaster gave permanence, but permanence came at a cost. Stone could hold dampness, trap heat, and demand careful drainage. So Maya builders compensated. Floors were plastered, courtyards were shaped, surfaces were angled. Water was encouraged to leave quickly before it could collect, rot, or destabilize the building. What looks to modernize like ceremony and monument was also, in many cases, a sophisticated response to tropical weather. This is where modern assumptions can fail us. We often imagine ancient cities as rigid, monumental, and somehow indifferent to weather. But in the Maya lowlands, weather was never background. It was an active force pressing against architecture every season. A plaza that failed to drain became a basin. A wall built in the wrong place could divert water into living space. A reservoir without maintenance could become foul. A stairway without runoff control could turn into a chute. Every rainy season tested whether builders had read the land correctly. Every dry season exposed whether the same design had captured enough water to justify itself. The system had to do both, or it failed. But the Maya did not stop at keeping rain out of their houses. They did something more ingenious. They turned the rain falling around their homes into a supply system. In the Puke Hills, one of the most important tools in that system was the cholton, a household cistern cut directly into limestone. Archaeologists described them as bell-shaped or beaker-shaped underground chambers lined with stucco to make them impermeable. Their necks were narrow, usually only about 50 to 70 centimeters across, and probably capped most of the time to limit evaporation and keep debris out. But the real brilliance was not just the cistern itself. It was the surface around it. The plastered platforms of Maya residential groups were often made slightly inclined, so rainwater would run straight toward the opening. In other words, the house compound itself became a water harvesting device. The ground was doing hydrology. The family courtyard was a machine. Imagine the builders making one. First, they cut through the limestone. Then they widened the chamber beneath the narrow opening, creating hidden volume underground where the sun could not steal it back. Then came the stucco lining, smoothed over the stone so water could be held instead of lost. Above, the surface had to be prepared just as carefully. A platform too flat would leave puddles. Too steep, and water would race past the mouth. What they wanted was control. A controlled fall, a controlled flow. A storm translated into storage. In that sense, a cholton was not a container added to a house. It was the house's underground partner. Now imagine the same compound during a storm. Rain strikes the roof. The roof sheds it. Water hits plastered ground that does not simply absorb the downpour and become a mess. Instead, it guides the water across a slight slope toward a dark opening in the center of the platform, down through the narrow mouth, into a hidden chamber below, where water is protected from sun, protected from much of the dirt. and saved for the months ahead. The same storm that might have flooded a careless settlement becomes, in a Maya compound, tomorrow's drinking water. This is the point where staying dry and storing water become the same story. The Maya were not fighting two separate battles, one against rain and one against drought. They were solving both problems with the same architecture. The successful house was not just one that stayed dry in a downpour. It was one that stayed dry precisely because the rain had somewhere to go. LIDAR has made this logic startlingly visible. In the Puuc region, the technology reveals chultans, communal aguadas, and the broader arrangement of settlements across a water-poor landscape. Researchers note that as many as 90 to 95% of chultan mouths in ground-checked areas can be detected in LIDAR imagery. Once they appear on the map, they are everywhere. Hundreds of ancient openings. Silent proof that household-level engineering was not a marginal trick, but a foundational habit of life. The Maya did not occasionally capture rain. They organized settlement around capturing it, and households were only part of the system. Beyond the domestic platform lay the community reservoir. In the same Puuc landscape where surface water was scarce, Maya communities also modified natural depressions into aguadas and built larger tanks and reservoirs. Some had berms around the edges. Some were fed by channels that expanded the drainage area and pulled runoff in from farther away. At certain centers, the combined capacity of reservoirs and tanks reached astonishing levels. At Xcock, researchers estimate that the documented reservoirs alone held about 104,000 cubic meters of water, roughly equivalent to thousands of chultans. That figure is more than a technical curiosity. It reveals scale. Maya water management was not just a household adaptation carried out quietly behind the home. It could be urban, massive, communal, and politically important. And these reservoirs were not simply open holes waiting for rain. At major Maya centers beyond the Puuc, archaeologists have found large storage systems linked to paved catchments, dams, canals, and even filtration features. Work at Tikal shows that expansive plaster surfaces covering plazas and courtyards sealed porous limestone and were canted to direct runoff into tanks. Researchers there also identified feats that included the largest ancient dam yet found in the Maya area, a switching station for seasonal filling and release, and sand filtration used to cleanse water entering reservoirs. In some regions where there were no permanent lakes or rivers, other scholars note that the Maya survived by creating plaster or clay-lined reservoirs that held rainy season water for later use. This matters because collecting water was only half the problem. Stored water had to remain usable. A reservoir that filled beautifully but turned foul was a trap, not a solution. So the Maya solution to rain was layered. First, get above it, then guide it, then store it, then protect its quality. That is a far more advanced sequence than the old stereotype of a jungle civilization passively accepting what nature delivered. In reality, the Maya were active managers of stormwater before the term existed. They understood catchment, sealing, conveyance, storage, and maintenance. They understood that a wet season could be squandered just as easily as a dry season could be feared. But there was another side to all this rain. Water you keep can save you. Water you fail to move can destroy you. That is why the Maya also built for excess. Archaeologists working at sites such as Copan and Nakum have emphasized that Maya cities existed in places vulnerable both to long dry spells and to seasons of excessive rainfall. At Copan, researchers describe a range of late classic water control techniques dedicated not to drinking water or irrigation, but to drainage and flood control. At Nakum, scholars note that excess rainy season water had to be channeled out of architectural complexes to avoid flooding. These findings matter because they force us to abandon a simplistic image of Maya water management as nothing more than storage. In many cities, the first task in a storm was not collecting the water, it was getting rid of it. That may sound obvious, but it changes the way we see Maya urbanism. A plaza was not just an open ceremonial space. A platform was not just a stage for kings. A causeway was not just a road. All of these could also direct water. At Palenque, for example, the Maya covered portions of existing streams with subterranean aqueducts that guided water beneath plaza floors, helping control flooding and erosion, while creating more usable civic space above. At Yucanal and other sites, archaeologists have identified canals, dams, causeways, and drainage works that appear designed to move water away rather than simply store it. The result is a very different picture of Maya engineering. These were not static stone cities waiting helplessly for the weather to decide their fate. They were landscapes constantly reshaped to manage motion. Water falling, water rushing, water pooling, water disappearing. Picture a major storm passing over a Maya center. Water drums across a plaza bright with plaster. Runoff races toward a canal mouth. A drain hidden in architecture carries part of that surge away from foundations. Elsewhere, a reservoir begins to rise. Elsewhere still, household platforms funnel smaller streams into chultans. The same storm is being handled at multiple scales all at once. House, patio, plaza, causeway, canal, reservoir, watershed. That is why the system feels so modern to us. Not because the materials were modern, but because the logic was systemic. The Maya were not merely constructing buildings, they were constructing a rain choreography. And the management of water was never purely practical. It was sacred, it was social, it was political. In Maya thought, water was not just a resource. It was bound to cosmology, ritual, kingship, and power. Researchers writing on classic Maya water management point out that rulers derived authority in part from what they could materially provide, especially water during the dry season, and spiritually provide, through ceremonies tied to rain, fertility, ancestors, and divine order. At sites like Nakum, water features and drains appear intertwined with symbolism, sacred landscapes, and displays of elite control. That means a functioning reservoir was not only useful, it was persuasive. It told people that order still existed, that the ruler could still negotiate with the sky, that society itself still held together. This political dimension helps explain why water management appears everywhere, from the intimate household scale to the most theatrical spaces of Maya public life. A ruler who could sponsor reservoirs, dams, catchments, or drainage works was not just funding infrastructure. He was organizing labor, demonstrating foresight, and making a claim about legitimacy. In a rainfall-dependent world, effective water management was a form of proof. It showed that elite power had substance. It showed that ceremonies had consequences. And when rain failed, or storage failed, or maintenance failed, the damage was never only physical, it was ideological. If the people who stood closest to the gods could no longer keep water flowing, what exactly was their power worth? So when we ask how the Maya stayed dry for days in endless rain, the answer is bigger than architecture. They stayed dry because they built settlements where water could be anticipated. They stayed dry because homes were elevated and breathable. They stayed dry because floors were shaped, not flat by accident. They stayed dry because runoff was not treated as waste until it threatened life, and not treated as treasure until it could be safely contained. They stayed dry because every surface had a purpose. The roof shed, the platform lifted, the plaster sealed, the channel redirected, the cistern swallowed, the reservoir waited. And behind all of that engineering was labor. Someone had to cut the limestone. Someone had to burn lime and make plaster. Someone had to smooth the floor so the slope was just enough. Someone had to line the cistern so it would not leak. Someone had to keep the opening covered. Someone had to dredge the reservoir, rebuild the berm, clear the feeder channel, and repair the damage after storms. This is easy to forget when looking at ruins. Water systems are not monuments that work once and remain eternal. They are living infrastructure. Their success depends on maintenance, memory, and cooperation. That human labor also helps explain why Maya water systems could be both resilient and fragile. For centuries, these strategies worked extraordinarily well. They allowed people to settle places that looked impossible on paper. They supported dense populations in the Puk Hills. They helped transform seasonal rain into stored security. They created cities where public life could continue above managed water, not despite it. But any system built on rainfall and upkeep is vulnerable to disruption. Too much rain can flood and erode. Too little can empty reservoirs and dry cisterns. And repeated extremes can break confidence in the people responsible for holding the whole thing together. Recent paleoclimate work has sharpened that picture. A 2025 study from northwest Yucatan reconstructed rainfall year by year, and found repeated wet season droughts lasting from 1 to 13 years between 871 and 1021 CE. The record suggests not a single bad year, but a series of climatic shocks arriving across a period of profound cultural change. Archaeologists comparing those droughts with northern Maya sites argue that different centers responded differently. Some declined earlier, some adapted longer. Some, like Chichen Itza, appear to have weathered certain stresses better than others for a time. This matters because it reminds us that Maya water management was never magic. It was brilliant, but it was not invincible. And still, it would be a mistake to tell this story only as a prelude to collapse. Because what the Maya achieved before those crises remains astonishing. Think about the elegance of the solution. In a place with punishing seasonal swings, they created houses that could dry quickly, settlements that rose above runoff, compounds that harvested the very storms that threatened them, reservoirs that stretched the usefulness of a season, and civic centers that redirected streams and floodwater with deliberate urban design. They did this without modern pumps, concrete, metal pipe, or powered earth-moving machines. They did it with observation, labor, stone, lime, and time. And they did it so effectively that, in many places, the traces are still legible more than 1,000 years later. Ancient canals still carry water. Buried reservoirs still shape the land. LIDAR still sees the mouths of cisterns cut by hands long gone. There is also something deeply human in the contrast between the grand and the intimate. At the scale of kingdoms, water management helped sustain political power. At the scale of a household, it meant something much simpler. A dry place to sleep, a clean floor, a hearth not drowned in mud, a vessel filled tomorrow because a storm passed tonight, a child inside while rain battered the roof, a family living not at the mercy of the season, but in a home designed for it. That is what makes the Maya story so compelling. Their engineering was never only about monuments. It was about ordinary survival carried out with extraordinary intelligence. And perhaps that is why the ruins can still mislead us. We look at a palace and see splendor. We look at a plaza and see ceremony. We look at a depression in the ground and see a hole. But to the Maya, each of those things could also be part of a water strategy. The palace stood where it stood because height mattered. The plaza sloped because movement mattered. The hole in the limestone could mean stored life. Once you understand that, the city changes. It stops being a collection of isolated buildings and becomes a working environmental system. Architecture, weather, and survival fuse into one design. And maybe that is the most remarkable part of all. Much of this brilliance was quiet. Not a king's inscription, not a towering pyramid, not the carved face of a god, but the slight tilt of a floor, the placement of a threshold, the decision to raise a sleeping space, the labor of keeping a cistern clean. The knowledge that if water lingered in the wrong place for one night, walls softened, floors turned slick, food spoiled, insects multiplied, and comfort vanished. Great civilizations are often remembered for spectacle. The Maya also deserve to be remembered for drainage, for catchment, for domestic intelligence, for making the storm livable. And that may be the most important lesson hidden in the Maya reign. The Maya did not conquer nature. They read it. They accepted that rain would come hard, that water would vanish, that stone, slope, soil, and season would decide the terms of survival. Their genius was not that they escaped those rules. Their genius was that they built within them so completely that a storm itself could be transformed from an enemy into an ally. Even now, modern archaeology keeps rediscovering that the ancient Maya city was never just architecture in the rain. It was weather management turned into stone. The rain fell. The roof shed it. The courtyard caught it. The cistern held it. The city endured. For days of pounding weather, for months of thirst that followed, and for centuries of civilization built in places where civilization should have been far harder than it looked, the Maya stayed dry, not because the rain spared them, but because they knew exactly where to send it.